comparison between hard switching and soft switching converters. First, what is meant by hard switching? And normally there are two types of switches available. One is called as control switch, another one is called as an uncontrolled switch. If you take diode is called as uncontrolled switch, thyristor, BJT, MOSFET, IGBT are called as control switch. The switch, if you give the supply, the switch will be gets turn on and turn off. This normal type of switching is called as hard switching. What is meant by soft switching means we are going to use LC circuit to turn on and turn off a device at zero current and zero voltage. In hard switching, the thyristor or BJT or transistor, it will get turn on and turn off at any time. Sometimes there will be voltage will be there, current will be there. But here in soft switching, the switch will get turn on at zero voltage and it will get turn off at zero current. That is called as soft switching. So here below there are two diagrams are there. First I will explain about hard switching. Next I will explain about soft switching. So if you take any device, there are two parameters are there. One is voltage, another one is current. The blue color is called as voltage and the red color is called as current. Initially the switch is in off state. At that time the voltage across the switch is high and the current is zero. Now I want to turn on the switch. So it will move from off state to on state. At that time, the current will start increasing and the voltage will start decreasing. So in the center, we can see this is point is called as overlapping. During this period, the switches gets turned on because it will not immediately it will not get turned on. It will take some time period. So there is an overlapping occurs. So due to that overlap means here the switching loss will happen. Next, I am going to turn off from on state to off state. So initially during the on state current will be high, voltage will be less. During on state to off state, the current is reduced to zero and voltage is increased to zero to maximum. So here also we can see the overlapping. Due to this overlapping, what will happen means the switching loss occurs. So if we are doing more time, the switches turn on and turn off. Overlap means more switching loss occurs in the circuit. Now, how to reduce this switching loss? For that, we are going to study about one new technique that is called as soft switching. So here we can see the voltage. Initially, the switch is in off state. Now, I'm going to turn on the switch. So see the current voltage is maximum and current is minimum. Now I am bringing this voltage to zero. After that I am going to turn on the switch. So now voltage is zero, current is increasing. Next, now the switch is in on state. I have to bring to the off state. So you have to bring the current to zero. After that you have to off the switch. So what will happen means here the switching loss is reduced. So to turn on the switch, we have to bring the voltage to zero. Now, if you want to turn off the switch, we have to bring the current to zero. This is called as soft switching. This soft switching is done by using the LC resonant circuit. Next slide we can see here. In the power electronics, we have studied about various switching characteristics. IGBT switching characteristics, MOSFET, BJT, thyristor, GTO, diode switching characteristics. So here, first we can see here, this is called as, initially the current is zero, collector current. This is the switching characteristics of IGBT. Here the collector current is minimum and voltage across collector and emitter is maximum. This is called as off state. And now I am going to do the turn on. So this is a time taken to turn on the switch from off state to on state. So here we can see some overlapping. Due to this overlapping, what will happen means the switching losses happen. If there is more turn on time, more switching loss will happen. And next, here we are having the off time from on state to off state. So here current is maximum to minimum, voltage is minimum to maximum. Here also some overlapping. If there is more overlapping, more switching loss. So during turn on time and turn off time, the switching loss is happening in all the switches. So this is called as hard switching. This is called as hard switching. So you have to minimize the switching losses. So you are going for the soft switching method. In the top, we are going to see two diagrams are there. First, you can see turn on. See, the blue color is a voltage. So voltage is from high, it is coming to low. And here, the current, the dotted black line is called as current. So here we are having, this is called as overlapping. If you turn the switch during this time period, if you turn on the switch during this time period, that is called as conventional hard switching. So you will get done, losses will be there. But if you turn off the switch this period, if you see this period, here the voltage is zero. If you turn on, so what that means, that is called as zero voltage switching. So the switching loss is reduced. Next, turn off. Turn off, the current is maximum. Now it is decreased. See, the voltage is increased from minimum to maximum. So when you turn on the switch, turn off the switch during this period, that is arrow mark, here this arrow mark is there. So that is called as conventional hard switching. Here the really loss is there. Now the current is now decreased and it comes to zero. When you turn on the switch, turn off the switch here, that is called as zero current switching. The switching loss is less. We can see some few points about hard switching and soft switching. In hard switching, the transistor is you have to turn on the transistor and you have to turn off the transistor. The transistor, it will move from on state to off state or off state to on state. It will take some time period. It will not immediately, it will not get turned on and it will not turn off because of the capacitor. So when you are turn on, or some capacitor is available, the capacitor will store the energy. During turn off, it will discharge the energy stored in the capacitor. So it will take some time. This turn on and turn off time period in the power electronics we have studied in the switching characteristics. The time a transistor needs to fully transition between on and off state produce wasted energy known as switching loss. During turn on and turn off, so a lot of energy is wasted, that is called as switching loss. Switching loss occur at the intersection of the voltage and current waveforms. The amount of switching loss in each transistor varies by the transistor type, by the manufacturer company, and the operating voltage. If you are having the transistor handle more voltage, more switching loss. Due to the hard switching, the lifetime of the transistor is reduced. We have studied various types of converters, DC to DC converters, AC to AC converters,